Okay. Started a recording too for, I think it was Bryn asked for that. But do you guys have any like specific questions you guys want to go over, or do you want me to just kind of start asking stuff from like the start? And if you like want clarification, then I'll clarify.
Sure. For me, I'm just like struggling with all of it, like how everything works together and like what it means, if that makes sense. So,
Okay. All right. I'll just kind of start from my notes, like what I have for lecture one, lecture two, lecture three, kind of. Um, so let's see, what's the first? Uh, I'm pretty sure we know, but everyone knows like independent, dependent variables, right? I don't need to talk about that.
no, yeah, we're good.
Okay. Um, do we want to go over the like nominal ordinal interval ratio?
Yes.
Okay. Um, so so for the four types, I'll write them out here. Nominal ordinal interval and ratio. All right. So to remember the differences for these is not super difficult if you like just look at the names themselves. So nominal has nom, which is like name. So this is like categories. It's things with names. Ordinal is basically like it's a ranked continuum of names. So it's like ordered names. Order. And then
Okay.
and then interval and ratio are the ones where like theoretically all the points, or in practice all the points are evenly spaced apart. But this one doesn't start from 0. So let me think. No true 0. And then this one has a true 0. And the easiest way I would say is this one has an O in it. And O is like 0, just to like really easily remember that. So true 0. So that's going to just be the simple thing there. Does anyone have any questions regarding those?
Okay, so like for mother's education group, that's like high school, college, and whatnot, would that be ordinal?
Yeah, that would be, yeah, you're right, that's ordinal.
Okay.
And I think one of the things that is also supposed to be like noted about that is like ordinal, the spaces in between don't have to be even. Like technically, like high school education, college education, and then further on, the amount of time between each of those like achievements is not the same, if that makes sense.
Yeah, thanks.
All right. Summation. So everyone like understands summation if it's just like let's see, like 1, 3, 5, 7. Like this is pretty easy for everyone, right? Where it's just you add everything.
Yes.
All right, so that's 16. All right. So then the way when summation gets harder is if you have, for example, x and a y, and you have like 1, 3, 5, 7, 2, 4, 6, 8. These are just like my examples. But when you see this in your equation, basically what that means is you have a table, and the first value would go with the first one, second with second, like that. Like this here is equal to this here. So then if you have like a summation where it's like the summation of x plus y, it would be the sums of this, this, this. So it would be equal to 3 plus 7 plus 11 plus 15. Which would be 36. So is there like any questions about summation stuff? Is that like kind of straightforward too?
So if that was like squared, that summation right there,
So if
then it
this
would
was
be,
squared like that,
yeah.
okay, then it would be like all of those values would be squared and then added together.
Okay.
If the square was like parentheses off from like the whole summation, you would square the 36. Is that what you would do?
If it was like this, then it would be 36. Yeah.
Okay, because I think there was like a couple like varying ones in the first homework that were like that, or like different placement of squares.
Mm-hmm.
Yeah, so if the square is like outside of parentheses like this, yeah, it would be this summation squared. But if the square is like inside, let me think, how would I do that? That's not. So you have like a summation where it's like so that this green one would be like this line of these. And then this green one would be the same thing if there weren't the square brackets, if that makes sense.
Good to know.
All right.
Are we doing like a whole kind of test review right now?
I'm just going
Please.
through and trying to find all of the things that would seem the most useful to probably go over.
Most of my
awesome.
issues are with like the last week of lectures.
Oh,
Yeah,
same.
same.
Oh, all right.
I'm really
That's the
struggling.
same for everyone. I could skip to that.
And we can come back maybe to other like concepts.
For sure.
Okay, yeah, that was definitely still useful, like the summation thing, and because yeah.
All right. So for the last week, we will start with the z-score. So what a z-score is let's say you have some study here and like your middle is like 60 and your standard deviations or whatever are like 15, so like that's like 75, and then this would be like 45. A z-score converts it to this normal curve where the center is 0 and the standard deviations are 1. So it's just like we know a lot of information about this graph, which is what that appendix section is in the back of the book. So if we can convert anything we find to the like standard one over here, it makes it really easy for us to find information. That's like the concept behind all of the stuff we did the last week, basically. So does that like concept seem clear? Because if the concept seems clear, it's easier to explain everything.
It definitely wasn't before, but now I didn't get the concept beforehand, so I had no idea what these scores even were.
Yeah, so basically that's what a z-score is. It's like a z-score is converting some like statistic you have in a study you did to this one really simple what's it called? Normal distribution. So it's like if you have the green one over here is like you did a study and you found these answers. If you convert your answers to z-scores, then you're using the like red graph on the right as your like comparison to for like percentages and stuff.
And then when we're looking it up in the book, like the z-score and like in the back of the book, is that when we're transferring it back to the green side?
So when you're looking up the z-scores in the back of the book, it's more so that you can figure out like percentages. So it's like the question would be asking like in the green graph, how many of the scores are above this like 75 here. So what you would do is you'd convert your 75 to the z-score, and then the z-score in the back of the book, you can look up and it just tells you the percentage.
Okay. Also, when we're approximating for like number 3A, I know in the group chat you like talked about that already, but I'm still kind of confused how to estimate instead of just using the z-scores.
So basically what the estimation is here's our like normal thing. I don't remember the exact numbers for 3A, but it was something like this is
70.
Oh, is this 10? So 70, and then it was 10 for the deviations?
Yes.
Okay, so 80, 90, 100, and then 60, 50, 40. So when it says approximate, so we had the value of like 85, which would be like here. So when it's asking for the approximation, it's based off of the like, this is like 68% of scores about, and then like this is 95% of scores about. That's like what the one rule, the 1, 2, 3 rule, where it's 68, 95, 99.7. So these numbers at the bottom aren't like what's important. What is important is that you know like let's see, what would be the easiest way to explain? So the values like in here, so these would be both 34% of the data roughly, because that's like the halves of this.
All right. So to approximate, it would be about 34 plus 17%.
So it would be, let me think. So there's 34 and 34, and then there's, what are the ones out here? It's like 12, 2, 0. 0.
So sorry if everyone else already knows how to do this.
Let's see, so
I have no idea personally.
Okay, good. I mean, not good, but like, you know.
so like roughly, wait, maybe I could write this cleaner. 1 second. Just to make it clear. All right. Whoa, why is that so skinny? All right. So this isn't like the exact numbers they use, but roughly this is like the percent in between each of these standard deviations. It's like, so the whole thing would be 100%. When it asks for your like approximation, basically what you're going to do is you're going to add up like all of these for the normal standard deviation, and then make an approximate guess for what this is. But also, kind of like what some of the people were saying in the group chat, if you wanted to, you could convert to a z-score. And then basically approximate a percentage that way, but that's like really exact. And I'm pretty sure the question is asking for you to just kind of like make your best guess based on a drawing.
Okay, so if it says approximate what proportion of freshmen scored higher than 85, and that's 85. So we'd add up all of them up to 85, and then whatever's left out of 100 would be our
Yeah, so
estimate.
it'd be like 100 minus this like whole area here.
Okay.
It might seem a bit weird. It's not like that difficult to do. The one thing I would note, when you're like making the approximation for this like last area here, is that like even though this is in the middle, it's not going to be like half of 14. It's going to be more because there's a lot more on the left side of that point than there is on the right side.
Oh. Why?
So like roughly a good guess for this area would be like 10 or so.
Okay. And there's more on the left side because it's like a normal distribution, so it goes like that.
Yeah, there's more on the left side because it's a normal distribution, and also just like if you look at the graph, like the left of the point is just taller than the right side of the point. So you know that it's not like exactly split in two by that.
Okay.
So that's like, wait. So roughly this would be like 4. It's like 94% or something is to the left. So like what percentage got more than 85 on the test? Like 6 or 7% or so would be like what your answer is on that homework question.
And it would be answered in a percentage?
Let me open the homework just so I can see.
Okay.
Honestly, it probably doesn't matter as long as you just like if you have a decimal and you turn it into a percentage, like as long as you do it right, I'm sure you'll get the credit for it. Unless they like
Makes
specify
sense.
one, unless they're like, oh, we want it in decimal form, or oh, we want it in percentage or whatever.
Okay.
It says proportion, so you might want to say like 1 out of 20, or say like 6 out of 100, or 3 out of 50 or something like that. But a percentage wouldn't be wrong.
Okay.
it's like the same idea, basically.
And to draw the proportion or to write the proportion, would it be like, I could do 3:50?
Yeah, or you could just write it out like a sentence, like just
Yeah.
3 out of 50 students.
Yeah, well, and
Okay.
according to like the notes say that a proportion can be like it's giving like the ace of spades example, like picking a card at random, 1/52, 0.019 or 1.9%.
Yeah, okay. So it can be
Okay.
given in any of those forms. Thank you.
Okay. Yeah, thanks.
All right. So that's like for 3. So z-score, is that, I think that's like the next thing to talk about here. So the conversion to a z-score is whatever score you're trying to convert minus the mean over the standard deviation. And in terms of like this, I would say just like remember roughly the formula. It'll be on the test, so, or on like the one sheet on the test, so you can just use that to like remember. But this is the calculation for a z-score. So like, let's say we're trying to find convert a score of 80 on something where the mean is 75 and the standard deviation is like 4. So this would be equal to 5/4 or 1.25. So then this is your z-score. What z-score means is like, if we bring up this one, normal deviation again, mean 0, standard deviations are like 1, then what the 1.25 means is like right here. That's 1.25. And like if you drew the graph that was of this right here, it would be the same shape with a point in that same spot, but that point would be the like 80 instead of the 1.25. So like, does that concept make sense? Okay. And then let's see.
The next one doesn't make sense for me is a difference, or like what each of the proportion in body and the proportion in tail mean in reference to the z-score table.
Yep. So basically what that would mean is, so here's our point, like the 1.25. So if you looked in that table in the back of the book at the part that says proportion in the tail, it gives you that area right there, because it's in the tail, or like it's in the smaller part of the graph, basically. So this is tail. If you look in the part of the book that says in the body, that gives you the exact opposite. So it gives you all of this here. And when you get these values, so the like table in the back of the book only goes from 0 to 3. So if, for example, you have a point that's like, over here on the negative side instead, then again, the tail is the shorter part of that graph, and the body is the larger part. Does that kind of answer the question more or less for that part?
Yeah.
Okay. So then there's also one other table. It's like a third, the third column or whatever in the back of the book that says like between tail and mean. So between tail and mean, if we have our point here again, between tail and mean is like exactly what it says. It's between. So if the tail is this whole part over here, it's this part like here to the center of the graph. And you can use that for like trying to calculate like between two values, basically. Okay, so that's like the start of the z-score stuff. Does that like in general make sense? Does anyone have any kind of outstanding questions about that?
So in general, the z-score is just like how many standard deviation units it is away from the mean.
Yeah, it's exactly that. It's basically converting whatever like study you're looking at to just like everything is in terms of standard deviations. So yeah.
Okay.
Right. Let's see. So then the other part after that, like the second day of the z-score stuff that we talked about in the most recent lecture, it's similar. It's using the same concept, but there's like a couple more equations for it because we're talking about it's like a distribution of means. So the theory behind this is like if you make a study and you do the study once, you might have a mean that's like here when the mean of your actual population is like here. But if you do a study over and over and over and over again, like more and more times, eventually you will end up with a study where your mean is the same as the mean of the population. So that's like the setup for the stuff we talked about in lecture on Wednesday. And then they talked about the standard distribution of means. So if you took the mean of this study, which would be like this point here, and the mean of this study, and the mean of all the studies that you do, and put them in a graph, it would be a standard distribution with the mean being the mean of the entire population. So just starting with that, like that's like the concept behind everything we did on Wednesday. Is there anything that seems really confusing about that? Okay. So then the standard deviations in this distribution of the means are different because basically all of the points in this graph are means. 1 second. All right, so since all of the points in this graph are means from different studies, you need to like calculate the standard distribution for this, which that standard distribution is equal to the standard distribution of the original studies over the square root of the amount of studies done, basically, or the amount of samples taken. I'll write that instead. And so I think on the homework, this is like what you're doing for question 5. Like all 3 of the questions, there's part of the question that starts by having to do this and ends with a z-score. So I think to like explain that, I'm just going to do 5A kind of. So for 5A, it says you do some study on some population. The mean of that population is 180, and the standard distribution for the original study is 30. A says you do 64 samples. And then it has this other part where it asks like above what score does 7% fall? So the first part of that question, you need to like essentially make your standard distribution. Your standard distribution is going to have this mean here, but it's not going to have the original standard distribution. It's going to have a standard distribution based off of the thing I said before, where it's standard distribution over the square root of samples. Which in this case is 30 over the square root of 64. And so in getting this value, you just know that the distance between each of the standard distributions is that. So that's like the first half of one of the questions for 5. Does that make sense? Or does anyone have questions regarding that first like part?
Is there a way to know, like, when we need to use the sampling distribution of the mean instead of just the normal one, besides like what it tells us?
So in the homework, it always asks for sampling distribution of the mean. So presumably on the test, it will be the same thing, but the other way to know is if the question includes like a sample size, then you're probably working with standard distribution of the mean instead of the regular standard distribution.
Okay, works for
And
me.
she said she'd give us the distribution table, right?
Yeah,
Like,
we're
we'll
gonna
have a
have like a
distribution table.
physical.
Okay, okay. Yeah, okay.
So now,
Perfect.
for the second part of 5, it's asking us this like purple thing up here, the above, what score does 7% fall? So that's the same thing as converting to a z-score. But the only thing is, in this case, we have a percent, so we know the z-score, but it's asking for what actual score. So we don't know the actual score, but we know the mean. We know our standard distribution. And then there's a z-score in the book. If I remember correctly, for 7%, it's 1.48. So then all you have to do for this is you're like isolate the x. So it would be like x is equal to 1.48 times 3.75 plus 180, which was equal to like 187.5 or something like that. I don't remember the exact number, but it's something like that. And so then you know that 7% of the scores are this or higher. And that's how you like answer 5 or 5A. And the only other thing to note is like on the test, there might be examples where we know the score and we don't know the z-value or the percentage. So all you would do is solve for a different x. So is there any questions in regards to like that concept or those questions or how to do that?
Is 5B the same thing?
Yeah, 5B is going to be the same thing, but you have to redo like both of the parts because instead of it being 64 samples, let's do a different color here. Instead of it being 64 samples, it's 16. So you have a different value here. And then it asks for 15%. So you're going to have a different z value or z-score for it also. But it's like the same formula or the same skeleton, just different numbers. Let's see. So then is there anything else in terms of the homework or anything like that that people have questions on? Because I think that goes to the end of the most recent lecture.
Actually, so now I'm on 3B, and it looks like it would just be the same answer, but also like the wording is a little bit different.
3B. So, on 3B. So 3B, if you randomly select a freshman from the University of Minnesota, what is the probability that a selected individual scored higher than 85 on a math test? So you could use either A, you could use the answer to A, which is your proportion, to just have like some percentage that represents the approximately. Or if you wanted to, you could convert to an actual z-score, which would be 85 minus 70, which is 15 over 10 is 1.5, and then whatever percentage is 1.5. So it'll be like 7% or so.
Okay, so it is gonna be like really similar to the first answer.
Yes.
Okay. Thank you.
Yep. Does anyone have any questions about like the kurtosis stuff? Or anything for the like sake of having that clarified?
Yeah.
Okay. So this is going to be like kind of similar to what I showed you in class the one time, where it's like the skews. So this one is the positive. So the easy way that she explains in class is that the skew follows the tail. So this is in the positive side of the graph. This tail is in the negative side of the graph. One of the things that also makes it easy is like in your head initially, you want to say like the opposite because like this is like the middle of the graph to like your eyes. But that's wrong. Where you want to like determine skew from is from the means. So you know it's a positive skew because there's a lot more to the right of the mean on this one, and then this one's negative because there's a lot more to the left of that mean. Let's see.
There was a question on the last homework asking like, if you had all this, how would the graph like look? Is there anything that you're supposed to put instead of just positive or negative, or is she also asking for kurtosis, or do you not know?
Let's see if I can find that question really quickly.
Okay.
So I think it's number 2 on homework 2. It's like if your data has a mean of 42, a median. Okay. So this will be our mean. It's 42. This will be our median. It's 32. And then this is our mode of 31. So because this is a mode, we know our highest point is here. And we know that the tail is going to be like that way because everything pulls towards the tail. And the easiest thing to remember is that if you have things like this, mean and median will pull towards the tail. If you want like a way to remember, if you have a dog likes to chase its tail, so the mean and median are going to chase the tail of the graph. That's like if you want your little easy way to remember. You can't really predict anything about like the platykurtic or the mesokurtic or anything like that, because you don't know how many data points are actually in the graph, because if you have a lot of data points, it might like even out a lot more, whereas if you only have a few, it'll become more of that like what's the tall one called again? Leptokurtic. But yeah, you can't really predict anything else except for the skew from the data that's given to you there.
Okay.
I still have questions about interquartile range.
Oh, okay. So, okay. So interquartile range. So if we have some data here, and I'm just going to do numbers counting up to 9. Okay. So, basically, wait, so to do the quartile ranges, it's based on your actual results and not like means. So basically how you find like your quartiles would be the median of the entire data. In this case, it's 5 because of that, like we have 9 or n plus 1 over 2 because it's odd. In this case, it's 9 plus 1 over 2. So 5 is our middle point. Now, for the quartiles, your lower quartile is going to be the median of the lower half of the data. So this would be Q1. And then this is Q3 would be in there. So including the middle point, now the bottom half of our data here is 5 plus 1 over 2. So the third value, that's where you're doing the quartile from. And then same thing for the upper half here, it's 5 over 2. The third value, 1, 2, 3. And then the interquartile range is the range from that quartile to that quartile. In this case, that range is 4.
Okay, thank you. That helps a lot.
I might just be dumb, but why is it interquartile range 4 when there's 5 values?
It's not the number of values, it's the range of the value.
Oh, okay.
So 7 minus 3 is 4. Yeah.
Okay.
That's a fair question though, for sure.
Wait, then also sorry, why do both of the green and the pink values equal 30?
Oh, when you do this equation at the bottom, it's not it's not using the values in the table. It's like the amount. So
Oh, okay,
when
okay.
you're doing this, it's like what you thought a second ago for the range, where it's the number of values matters. But for the range, it's the actual range of the numbers.
Okay.
All right. Besides that, the only other thing is, are you guys confident on if you have to find variance and standard deviation?
I was just thinking about that and trying to decide if I was. Is the square root when we're finding the standard deviation, that's over the whole entire equation, right? Like once we find variance, we just
Yeah,
square root it.
so yeah, standard deviation is just the square root of the entire variance.
Okay.
So if we wanted to just do like a simple one with 1, 2, 3, 4, 5, oh wait, that's not a good one to do it with actually.
Wait, why not?
Because the variance of 1, 2, 3, 4, 5 is going to be 0.
Oh,
Because everything's evenly spaced from the mean.
gotcha.
Yeah. So like 1, 3, 4, 7, 9, mean is gonna be 8 plus 16, 24 over 5. That's like the mean of that. And then the variance is going to be like or wait, I wrote this backwards. This is just a lot of writing. All right. So that's what the variance would be. If everyone sees how you get this, we don't really need to solve it out right now. I'm just going to say like x is equal to this. And then in the case of standard deviation, the standard deviation is going to equal the square root of that x. Does that make sense? Okay.
What do you use variance for?
Variance is not that useful by itself. It's mainly a means to finding standard deviation. What variance like means or suggests is like let me think how would I on average, how far is everything from the mean? But it's like
I think the variance is just kind of a way to get that distance from the mean without having to deal with negative numbers, essentially.
yeah, it's like variance is more of a means to an end than it is something you really care about.
Okay.
All right. Is there any other like I guess like terms or anything that people want help defining that maybe just seem like fuzzy or whatever? Because we've basically covered all of the math that is going to be a part of the test already. So
Are you gonna put this video in the group chat?
considering it, I think the file size is going to be big, so I
Okay.
might upload it to like a YouTube channel or something and then put a link.
Oh yay, help everyone, not even just our class.
You might also be able to add it to your drive and then have a link to that drive file.
Yeah, I could probably do that too. I'll do one or the other.
Okay, thank you so much, by the way. This helped a lot.
Yeah, thank
Yeah.
you.
Thank
Yeah, no
you.
problem.
Do you want to be like a teacher or anything? Because all the like memorization stuff too, so helpful.
I mean, maybe, I don't know. I want to be a psych major, but I know that there's ways that I could be a teacher with that. So whatever happens, happens. All right.
Well,
All right.
see you
Have a good
tomorrow.
rest of your night, everybody.
Thank you.
Thank you. Bye.
Bye.